Okay, Chapter 5, Lesson 1, Solving Inequalities. First of all, let's remember what our inequalities are. Remember, our inequalities are less than or equal to, greater than, or greater than or equal to. So when we are going to solve, remember, we're going to follow our solving rules, which are distribute, combine like terms, add, subtract, multiply, or divide. The only change we're going to have with solving inequalities is on the multiply or divide rule. If you multiply or divide by a negative number to get x alone, you must switch your inequality. All right, on this first one, we're going to match each inequality with its corresponding graph. When we go to graph inequalities, maybe we should take a few reminder notes. To graph inequalities. First thing is if it's a less than or equal to or a greater than or equal to, we have a solid circle. And if it's just greater than or just less than, we have an open circle. X less than a number points to the left. X greater than a number points to the right. But if you have a number less than X, it points to the right. And a number greater than X, it points to the left. So those ones are the most confusing because a lot of times we've learned that since X is on the left, we point our arrow whichever way the inequality is pointed. But in Algebra 1, we're going to have a lot of numbers that are on where X is on the right. And so those are actually opposite of your inequality. So this first one right here, in order to solve for X, I'm going to add 15 on both sides. And so that leaves me with 7 is greater than or equal to X. So first of all, because it's greater than or equal to, I know it's going to be one of my solid circles. And it's kind of hard to read, but on this one, the only open circle is D. These other three are solid. And so I'm looking for the one that is solid on 7, which is B. Number 2, I'm going to have to combine like terms because there's no distribute. Going to subtract 4x to both sides, which gives me 3 is less than x. I know I'm looking for one that has an open circle because it's just a less than. It's not a less than or equal to, and that only option is D. On number 3, I'm going to have to subtract 7x to both sides, which leaves me with x is greater than or equal to -4. So I'm looking for the solid one on -4, which is A, and x is greater than -4, which points to the right. And on the last one, I need to subtract 12 to both sides. So x is less than or equal to -3. So I know it's a filled in circle on -3 and pointed to the left, which is C. Solve each inequality, check your solution, and then graph it on a number line. So this first one starts as r minus -5, which we know from our previous lessons, minus negative turns into plus a positive. So I really have r plus 5 is greater than -2. Subtract 5 to both sides, so I have r is greater than -7. Because it's a greater than, I'm going to put an open circle on -7. And it says that r, or the answers, are greater than -7. So all of these numbers to the right are the ones that are greater than -7. Now, when you do this on your homework, I don't need all of the numbers on the number line. I just need your answer clearly marked with whether or not it's an open or closed circle. And then put your arrow on the top, which way you're pointed, so that I know for sure what your answer is. Okay, on number 6 here, I'm going to have to do a 2-step. The first thing I'm going to have to do is subtract 8 to both sides. Oh, just kidding. I need to combine like terms first, which is subtract 3x. So that leaves me with 8 is greater than or equal to x. So I know that it's going to be a solid circle on 8 because it's greater than or equal to. And this one, because my X is on the right, if I read it, it says 8 is greater than all of the answers. 8 is the biggest out of all the answers. And so I actually need to point this one to the left. You can also pick an answer and check it. So like I could pick 6 and I can ask myself in the equation, is it true? Is 8 greater than or equal to 6? Yes. Is 8 greater than or equal to 7? Yes. Is 8 greater than or equal to 5? Yes. So I know that I pointed the right way. If I would have tried to point this way and then check my answer, I would ask myself, is 8 greater than or equal to 10? The answer is no. So I would have known I pointed the wrong way. On number 7, I'm going to go ahead and add 2.5 to both sides. So that would give me n is greater than or equal to negative 2.5. Just put a solid circle in between the negative 2 and the 3. And it says the answers are greater than negative 2.5. So it points to the right. Define a variable, write an inequality, solve the problem, check your solution. The sum, which means add, of a number in 17, so I'm going to add a number in 17, is not less than 26. So it could be 26, but it's not less than 26. So it needs to be greater than or equal to 26. Subtract 17 to both sides, and you get x is greater than or equal to 9. Solid circle on 9, and greater than or equal to 9 is to the right. Twice a number, which we know twice a number is 2x, minus 4 is less than 3 times the number, so 3x. Combine like terms on this one. I'm going to subtract 2x to both sides. So that gives me negative 4 is less than x, 1x. And so this time it's an open circle on negative 4. And it says negative 4 is less than all the answers. Negative 4 is the smallest of all of the answers. And so I point to the right. 12 is at most. The most it could be is 12. A number decreased by 7. So since 12 is the most, everything else is going to have to be below it. So 12 is greater than everything else. And then it says a number decreased by 7. Add 7 to both sides and I get 19. Closed circle on 19 and pointed to the left. 8 plus 4 times a number is greater than 5 times the number. Subtract 4x to both sides, and 8 is greater than x. 8 is greater than all of the answers. 8 is the biggest out of all the answers, so it points to the left. The troposphere extends from the Earth's surface to a height of 6 to 12 miles, depending on the location of the seizing. If a plane is flying at an altitude of 5.8 miles and the troposphere is 8.6 miles deep in that area, how much higher can the plane go without leaving the troposphere? So here's my picture of the troposphere. I don't really know what it looks like, but I do know that this is 8.6 miles. I have this plane that is flying at 5.8 miles. And I want to know how much higher can my plane go, so x, without leaving the troposphere. So I know that I'm at 5.8, and I want to know how much higher, so plus x, but I do not want to leave the troposphere. So I need to be less than or equal to my 8.6. Subtract 5.8 from both sides, and you get less than or equal to 2.8 miles. Mature soil is composed of 3 layers. The uppermost is the topsoil. Jamal is planting a bush that needs a hole 18 centimeters deep for the roots. The instructions suggest an additional 8 centimeters depth for the cushion. If Jamal wants to add even more cushion, and the topsoil in his yard is 30 centimeters deep, how much more cushion can he add and still remain within the topsoil? So here's my topsoil, and Jamal is digging a hole. Oh, my topsoil is 30. And Jamal has dug this hole that's 18. Then it also suggests another 8. And he wants to know how much more can he add and still be within the 30. So he knows he needs 18 plus another 8 for cushion, and how much more to stay within the 30, so less than or equal to 30. So combine like terms here gives me 26 plus x. Subtract the 26 gives me 4 inches left.